Hey everyone, Jerry from Llama Index here, and the topic of today's talk is on from RAG to knowledge assistance. Hey everyone, Jerry from Llama Index here, and today I'll be talking about going from RAG to knowledge assistance. This is a version of a talk that I've given at various conferences in the past few months, but hopefully this captures at a high level how we think about the progression of use cases going from basic RAG chatbots to things that are more sophisticated and drive more knowledge automation throughout different use cases. So a quick background on the company. Llama Index is the fastest way to help you build production quality LLM applications like chatbots and agents over your enterprise data. We have two main products, an open source agent orchestration framework, as well as Llama Cloud, our enterprise knowledge management platform that helps manage a lot of the data parsing, indexing, and retrieval. We have one of the leading developer platforms and communities for Gen AI with 200,000 plus followers on LinkedIn, lots of monthly downloads, integration, so on and so forth. A quick overview of our product offerings. Llama Cloud is our enterprise RAG platform that helps users connect their unstructured enterprise data to LLM agents. We handle a lot of the data ingestion, processing, the new ETL layers that need to happen in order for you to build context-augmented LLM applications. This basically runs it all as a managed service and provides some core value props. So first is you're able to get immediate production deployment of any sort of multimodal RAG-based knowledge assistant over your data. You can set this up super easily without having to worry about like very fine-grained parsing, chunking algorithms. You get best-in-class performance over different types of complex documents. And of course, it's a core building block that you can plug into a broader agentic workflow. Now, our open source project, which has been with us since the beginning, is basically a core toolkit for helping you define agentic workflows over your data. We'll talk about this in just a bit, but this basically enables you to combine the data interfaces with LLMs embedding models and stitch together very complex agentic flows to help you deliver production LLM use cases. We've seen a lot of prototypes in the past year or so, but actually productionizing a lot of these capabilities has been relatively challenging. So first, let's define what it means to actually build a knowledge assistant and then talk about what it means to productionize it. A knowledge assistant is basically some sort of interface that takes in some input from a human and gives back an output. And the goal for anyone building a knowledge assistant is to handle inputs of arbitrary complexity and generate outputs of arbitrary complexity. These inputs could be simple questions, and you could emit simple responses. This is basically what naive RAG chatbot does these days. But it can also ideally take in more complex questions, broader research asks, and then output more sophisticated outputs. So going beyond short answers into, for instance, like structured outputs or research reports. And besides, generating entire artifacts, ideally it can actually, take actions and do things in the world as opposed to just, synthesizing a short response to the user. And so if we look at the current state of RAG, which basically is that, simple input in, simple input out type pattern, it doesn't really help drive knowledge automation to the end users. And so therefore, the actual ROI to the end user ends up being somewhat limited. These types of basic chatbots that people have tried to productionize oftentimes, hallucinate over different types of questions, so they don't actually give back the right response over your data. As a result, you can't actually use that for a lot of things that actually save you time. And so the level of decision-making enhancement is somewhat limited. So we think about, how do we go beyond the basic RAG stack into adding in, these emerging agent capabilities to build a knowledge assistant that's simultaneously more advanced, but also production ready. And as a result, it actually generates a lot of greater amount of end user value. We think there's 4 components towards building a better knowledge assistant. First is having a high quality and data and retrieval interface. The second is leveraging some agentic reasoning layer in front of your inputs to actually process these inputs in a manner that allows you to solve more complex tasks. The third is extending beyond a simple chatbot response into thinking about what are more sophisticated what are more sophisticated forms of outputs that we can generate and provide to the end user. And how do we, leverage not just agentic reasoning in the decision making for the query layer, but actually use it to generate more sophisticated outputs. And the last piece is helping you build a more scalable full stack application, going from the code that lives in a notebook to actually generating something that's an entire web application. So starting off with high quality data and retrieval. We think that, first of all, you basically need this new type of ETL layer for LLMs in order to build a sophisticated LLM application. The garbage in, garbage out principle of traditional machine learning still applies here, and we think that good data quality is basically a necessary component of any sort of production LLM app. In the RAG space, for instance, this ETL layer looks something like, you want to take in some unstructured data, parse it, chunk it, and then put it into a vector database. Of course, like doing those operations in a very simple manner is easy, but doing it well is hard. And the issue is that if you don't do it well, then if you process your data the wrong way, then no matter how good your LLM is, this is going to lead to hallucinated results over your data. A particular case study that we're actually interested in is this idea of complex documents. A lot of documents can be classified as complex. And so, when we think about the space of like user-generated documents out there, there's like PDFs, PowerPoints, Word documents, HTML files, Excel sheets. A lot of them can have a variety of different elements within it. That's not just like clean text. It could have tables, charts, and images. They can have like, 2-3 column layouts, scanned documents. They can have headers and footers as metadata. And actually building even just like a basic RAG stack over this type of data can be challenging. So when we took a look at this problem space and we thought about, okay, what are some of the components that we can actually help build to try to make this part a little bit more advanced? Well, you start off with one of the first pieces of ETL, which is parsing. And so that's where we came up with Llama Parse. It's an advanced document parser specifically to help reduce LLM hallucinations. These numbers on the right are actually a little bit outdated. We're at 70 million plus pages processed right now on Llama Parse. We launched it back in February, and it's already powering a lot of kind of like advanced RAG and agent stacks throughout different companies. One of the core capabilities that Llama Parse has that's really, really good is being really good at parsing these complex documents, specifically with tables, charts, and images. And so as a result, you're able to build, even if you're not adding on the agent stuff yet, advanced RAG chatbots over different types of complex real-world data. This includes everything from like earnings decks or slide decks in general with a lot of graphics and charts to 10K annual reports with a lot of like text and tables, to, for instance, like accident claims where you're able to which have forms with keys and values all spread throughout the page, to Excel sheets where you might have like multiple tables on a given sheet. So parsing is one thing. That's a core step towards being able to actually understand all the elements within a document. And then the next step is being able to actually index this data properly so that you can actually serve it up to LLMs in the right manner. So one technique that we've been proposing that basically gets around some of the limitations of naive RAG chunking and indexing is basically combining advanced hierarchical parsing or parsing with hierarchical indexing and retrieval. So having something that's a little bit more sophisticated than, for instance, like splitting your text every 1,000 tokens or so, and actually being able to model your document as a document graph and index all the different elements of your document graph. So this then allows you to actually retrieve semantically coherent elements during the retrieval process and feed that into your language model during synthesis. So the few steps that are required for end-to-end parsing, indexing, retrieval, you first parse the documents into these elements, so text chunks, tables, and images. And then for each element, you extract one or more text representations that can be indexed. So whether or not the source documents like text, table, or diagram, you extract out a summary representation, index that summary representation, and then during synthesis, you basically retrieve the index representations, which we call nodes right here, and then basically dereference them into the source element. So with the rise of multimodal models nowadays, they can take in text, images, and nowadays like even audio. And so this pattern is actually a pretty powerful technique for being able to still leverage the capabilities of text-based indexing or just indexing with a vector, but having them link to all sorts of different elements within the document. And so this we have on the open source side, and so we have a lot of users composing this to build their own advanced RAG stacks, and this is also part of Llama Cloud, our enterprise RAG platform. If you don't want to set up and maintain this type of code yourself, Llama Cloud basically gives you an end-to-end solution to load in, ingest your data, process, index your data, and then retrieve from that data using some of the kind of advanced multimodal capabilities that I just talked about. And so, you're able to set up a RAG pipeline very, very quickly in minutes, get really good performance over different types of complex documents. And we add in an additional layer of enterprise security so that, as a developer, you don't have to actually deal with a lot of the systems or kind of security level challenges on your own. We'll give a demo of Llama Cloud potentially in another video, but basically, if you have any of these use cases, for instance, like slide decks, a SharePoint directory with a million documents, a million PDFs, that's basically the perfect use case for us. And so I'll have some links at the end if you're interested in talking to us about some of these capabilities. And Llama Cloud basically dramatically accelerates time to value with high performance. And so basically being able to first get users to build and ship and productionize a RAG use case super quickly so that you can not only just work on one, but multiple RAG use cases that are high quality, which then feeds into the downstream agentic orchestration that you want to build. So you're able to spend, as a developer, time on building agents as opposed to tuning RAG stuff. And we also help users get state-of-the-art quality, of course, over their data. So that was high-quality data and retrieval. And as the next section, let's talk about agentic reasoning over complex inputs. So naive RAG works well for pointed questions, but fails on more complex tasks. Even if your data pipeline is good, you're using some of our components, or you're basically using some advanced parsing indexing stack, the issue is still that the LLM is really only used for generation as opposed to reasoning. And so for basically any type of more complex question, whether it's summarization, comparison, multi-part question, high-level research task, then this current setup where you're only using the LLM to basically first retrieve top K chunks and feed it into the prompt window is not going to be able to handle these more complex questions. This warrants adding in an agentic reasoning layer in front of the query and to process the inputs before it goes to the different data interfaces, for instance, a vector database. The goal here is to treat every single data interface as a tool and then use agent reasoning loops with the different components within an agent to process the inputs and tackle these complex tasks. This can potentially do stuff like chain of thought, DAG-based planning, query decomposition, break the task down into similar steps, and figure out how to use these different data systems, whether it's a vector database, SQL database, graph database, web search, or more, as tools to basically achieve the goal. And so instead of directly feeding in the end user input, embedding it, and putting it into a vector database, this agent reasoning layer enables developers to basically build personalized QA systems capable of handling more complex tasks. If we look at the space of different types of flows that users can basically build, we see that there's both more constrained agentic flows as well as more unconstrained flows. There's many different definitions of what an agent is. And for us, we basically think that an agent is anything where you're using LLMs or non-zero LLM calls to help decide the control flow of a program. So, if you didn't use any LLM calls at all, then it would just be a normal code program where like the control flow is defined by if-else statements, while loops, and more. But here, an example of something that's this agentic, but maybe constrained, is where you're starting to introduce LLM calls to decide certain actions to take, while still, determining the overall control flow through kind of human input. For instance, you could use an LLM-based router to make an if-else choice, but still make sure that the rest of the flow is kind of like pre or statically determined. An unconstrained flow would be something like a full React architecture or a function calling agent, where given some input task, the agent orchestrator can dynamically figure out what tools to call, basically, and iterate on calling these tools until it's finished. And this basically abstracts away a lot of both like the if-else statement handling as well as while loop handling from you as a user or developer writing the code to having the agent just figure this out. And so it can follow, for instance, a dynamic pathway. It might call like tool 1 or 2 for a given input, but then call tool 2 or 3 for another input in order to solve the given task. And so it's more unconstrained in the sense that you're not explicitly telling the agent that it needs to do X number of things and handing off more of that control to the LLM. Within the spectrum, obviously you want ideally some sort of framework that can help you tackle both. And so we think an agent orchestration framework should allow you to basically define these types of workflows in a way that feels similar to writing normal code, but still takes advantage of some of the unique properties of building agentic systems. So we basically have this full-fledged agent abstraction and tooling and ecosystem called Llama Index Workflows. And so Llama Index Workflows has a few key properties that make it a really nice toolkit for you to build agentic systems over your data. First, it's event-driven. So you basically model every step as listening to an input event and then emitting an output event. Similar to how you imagine a general agent would behave, it's listening to some sort of like sensory input and emitting an output. It's composable, so you can piece together more fine-grained task-specific workflows into higher-level multi-agent workflows. And another piece I want to highlight is it's actually very similar to writing just kind of like plain Python. You basically define a Python class with a set of steps. Every step is just a Python function, and it's low level enough so you can basically define whatever you want within that Python function. And so this allows you to basically still code using a mix of both like LLM calls. For instance, if you use like an agent loop under the hood, or define your own control flow through just like if-else statements and while loops. The last piece is we have core integrations with a lot of different partners to basically help you debug and observe the outputs, and workflows are also easily deployable to production. And so we have surrounding tooling that help you not just only define this workflow in a notebook, but actually this event-driven architecture helps us actually deploy this as a service in a production setting. So that was a general overview of both agentic RAG, like reasoning over your inputs, as well as it covers some of the core agentic tooling that we provide in the core framework. And the next section is, looking at some use cases where you're not just applying agentic reasoning on the inputs, but actually leveraging agents to help with output generation. So we think that agents, or at least the promise of it, is far beyond just like core search capabilities. Agents should have the capability to not only generate chatbot responses, but also produce knowledge artifacts and also take actions. And the more that we can trust agents to do this, and of course this is a work in progress, then the more that this actually provides higher value to the user of this AI system. We are specifically excited about report generation. We think that report or artifact generation is a broad category where you're basically, instead of, again, generating a chatbot response, you're generating a full artifact. This is pretty broadly defined, but we can go into what specific use cases there are. And the idea is to actually give the end user a full unit of output. And so their primary role is to edit and review it as opposed to having to create stuff from scratch. Some examples of use cases which basically fall in this category of artifact generation include generating a full research report, like a PDF, generating a full slide deck or presentation, doing form filling. So, whether it's filling out your personal tax form, filling out, a questionnaire or due diligence thing, being able to take in some template, given some knowledge base, automatically fill that out, and then filling out, for instance, like an Excel sheet, right? So that you can fill in all the different values based on, again, a knowledge base. This is a core use case, and we've increasingly seen this among some of our customers and users as well. There's a few examples that we'll go over in subsequent videos of different form factors of report generation. So this includes, for instance, like multi-modal report generation, where you can generate like a output or some sort of structured report with like text, tables, and images. And so, for instance, let's say you're generating a survey paper or a general, kind of like data analyst report over some bank of documents. You can do research over these documents and generate interleaving text tables and images responses. The typical architecture that we see is composed of like 2 steps, potentially with other things in the loop if you decide to add that. And this includes a researcher. So a researcher that retrieves like relevant chunks and documents and puts them in a data cache, and then also like a writer. And so this uses the data cache to generate like a structured output of interleaving text, table, image blocks. Another use case that, for instance, that we're pretty excited about is being able to generate a response to an RFP. This is just another example of artifact generation, but RFPs are typically in the form of like an implicit template. It's a request from a vendor to basically that, and it has instructions within the template that help define what it's looking for in the response. And as a vendor, you need to use your context knowledge, your knowledge base, to actually fill in this form that adheres to the guidelines. So, we'll go over this again in a separate video, but we have a full notebook and architecture that shows you how to use Llama Index workflows plus Llama Cloud and Llama Parse to appropriately index your knowledge base, parse the RFP, and create an agentic system that can finally generate a response to the RFP. Another example is Excel form filling. So oftentimes, as an analyst, a financial analyst, you might be given some sort of template that you need to fill out by doing research on some set of companies. And so by creating an agentic system where you can go, row by row or column by column or cell by cell, again, given some knowledge base, be able to figure out and parse the numbers and be able to fill in these numbers into the Excel sheet. This relies on, again, both in a high quality data pipeline, because if you parse tables the wrong way, you're going to fill in the wrong numbers, but also, of course, agentic workflows with components like human in the loop. We mentioned this, but we think that being able to take actions and generate sophisticated outputs potentially lead to a higher ROI in terms of time savings and capability improvements. And it's going to take a little bit of time to get there, but we're very excited about this use case. We think that as LLMs get better, as they are able to automate more and more actions on the research and generation steps, then at the very least, you're able to start to see more and more sophisticated outputs from an AI agent with fewer human in the loop steps and lower amount of review time put in to actually create any sort of knowledge work. And the last section is, once we've created this overall algorithm or agent architecture, figuring out how to deploy this in a production setting. We're very excited about the architecture and components that developers need to serve a complex agentic workflow to end users as a production application. Some of the core requirements here include being able to encapsulate all the workflows behind an API, creating a standardized communication interface so that you have an agent API that can communicate with other agents or with other tools, being able to scale up the number of clients, but also the number of agents within your overall architecture. Can they communicate with each other? Can you add or remove some? being able to incorporate human in the loop aspects so that the agents can pause execution when needed to wait on human inputs, and also providing the right tooling for developers to observe what's going on with their agent systems. Llama deploy is our realization of that and directly integrates with Llama index workflows. Llama deploy helps you deploy any sort of agentic workflow that you define as microservices and allows you to model every agent workflow as a service API, allows you to model communication between the workflows through a message queue. It gives you back a core, easy to use API server that you basically plug in your workflow, deploy it through Llama deploy in one line of code, and you get back this API server that can then serve client requests. And so it's a great tool if you're, for instance, thinking about hosting your agents on some service, and includes inbuilt support for stuff like human in the loop as a service, state management, and more. Some other bonus areas here is, besides the backend deployment piece, we're very excited about the full stack UXs that are made possible with agents. For those of you who don't know, we basically have a cheat code project called Create Llama. Create Llama is a one-line CLI command that allows you to basically create a full agentic template with a ton of different configuration settings. You know, you can choose the front end, back end, choose the model you want to use, the storage system, and throughout this CLI configuration, basically generate a full stack project that you can immediately get started building your application. It has native integrations with Llama Cloud to help set up your data. It has integrations with Llama Index workflows. And this video right here shows you an example of a multi-agent, report generation example. There's also RAG app, which is basically a no-code version of Create Llama. Similar to GPTs, you can just input some parameters between like different agent systems, write some prompts, and then basically create a multi-agent system that can solve different types of tasks. It's a fantastic project by one of our core community contributors, Marcus Schaezer. That's it. Thanks for your time. We'll have follow-up videos on basically going more in depth on a lot of these different components, from Llama Cloud and Llama Parse to a lot of the agentic workflow tooling, and doing deep dives into showing you how to build a lot of these applications and use cases. So if you're looking for links, feel free to check these out, and otherwise, see you next time.